All right, guys, so as we look at this, this is the second page, front and back. Couple adjustments on number 18. The shaded region is supposed to be outside of the polygon and inside of the circle. So just like how in any compound figure, we're going to find the area of the larger thing, which in this case is the circle, minus the area of the smaller thing, which is the regular polygon, which is the pentagon in this problem. So we have another thing. The 5 is supposed to be here, and there's supposed to be a radius. Just one small thing. Okay. As we look at this area of a regular polygon, so we have the area of the circle, so area equals pi r squared. R in this case was 5, r squared is 25. So 25 pi is the area of the circle, but we are going to subtract the area of the regular polygon, which is 1/2 apothem, side length, number of sides. The apothem in this problem is 4, the side length in this problem is 6, and the number of sides is 5. So 24 is 4 times 6, half of 24 is 12 times 5 is 60. There are no units in this problem, so this will be units squared. I cannot subtract 25 pi from 60 and 60 because they are not the same, so this is going to be the same. You might think that this is going to be a negative number, but remember pi is 3.1415, and 25 times 3 is going to be 75. If we look over here, we had these similar problems last on, let's say that Monday. Portion of the regular decagon, remember a deca is 10. As shown, find the individual indicated angles. So angle 1, if you draw a circle around the central or the center of any polygon, you create a circle with how many ever sides pieces of pi. So we're just going to take 360, divide by 10. That means angle 1 is 36 degrees. Angle 2 is just half of whatever angle 1 was. Those 36 divided by 2 is 18 degrees. And then angle 3 is the complementary angle. So 90 minus 18 is 72 degrees for angle 3. So 72 degrees, 18 degrees, and 36 degrees are going to be the angles for that problem. Down here, we're dealing with circles. So just working back and forth and all of those things. So it's asking for the area if the radius is 8. So area equals pi r squared. Area equals pi 8 squared. That means area equals 64 pi inches squared. So 64 pi inches squared. On number 21, if they told me if the area was 4.41 centimeters squared, then find the radius. So area equals pi r squared. Area is 4.41 pi equals pi r squared. Divide by pi on both sides. That eliminates that, leaving you with 4.41 equal to r squared. Take the square root of both sides, and r equals 2.1 centimeters. Number 22, if the radius is 11.3, what is the circumference? So circumference equals 2 pi r, so plug in what I know. C equals 2 pi, my radius is 11.3, so double 11.3 is 22.6 meters. Circumference is 18 pi, so circumference equals 2 pi r, looking for the area. The only relationship between area and circumference is that r, so area equals pi r squared, so I do need to find out what r is. So if the circumference is 18 pi, let's plug that in. 18 pi equals 2 pi r. Divide by 2 pi on both sides. Pi's cancel out. 18 divided by 2 is 9, which is r. So then I'm going to go ahead and plug that in for r. So that means area equals pi 9 squared. 9 squared is 81. Don't forget about that pi. And then since it's area, feet squared. For 24, if the area is 39.69 pi centimeters squared, then what is the circumference? So just like the other problem, the only relationship between area and circumference in terms of the formula, besides that pi, is that radius. So circumference equals 2 pi r, area equals pi r squared. So if my area is 39.69, 39.69 pi equals pi r squared. Divide by pi to get r mostly by itself. So 39.69 equals r squared. Take the square root of both sides. That means r is 6.3. Come over here and plug r in. C equals 2 pi, my radius, which I just found, is 6.3. So that means my circumference is 12.6 pi centimeters. Over here, the circumference is 15 pi. Circumference equals 2 pi r. We're looking for the radius. So 15 pi equals 2 pi r. Divide by that 2 pi. Pi over pi is 1. 15 over 2 is 15 halves, or 7.5. So r equals 15 halves. Or you could also write it as 7.5 inches. We're on the back side now. These are our regular polygon questions. This one, my apothem is already in there. I have my side length and I have my number of sides, so this one's just everything's given to you. So area is equal to 1/2 the apothem times the side length times the number of sides. So area is equal to 1/2 the apothem, which is 15 square root of 3, times the side length, which is 8, times the number of sides, which is 6. So if you go to your calculator, 15 times 8 times 6 is 720. If I divide that by 2, puts me at 360. Don't forget the radical 3, but the area of this guy will be 360 square root of 3 units squared, since there are no units given. On this one, this would be considered the radius, which means I need to draw in the apothem, putting my right angle there. Remember, an equilateral triangle, all of these angles are 60, which means if you cut it in half, that makes that the 30. That makes that the 60, which means I was giving you the hypotenuse. So basically, this is the triangle I have. 60-degree angle, 30-degree angle, 7 square root of 2. Makes this the short leg, makes this the long leg. Hypotenuse equals short leg times 2. So the hypotenuse is 7 square root of 2 equal to the short leg times 2. If I divide by 2, that means my short leg, which is also my apothem in this problem, is 3.5 radical 2 equals short leg. So this right here, which is my apothem, is 3.5 radical 2. So to get to my long leg is equal to short leg times radical 3. Long leg is equal to short leg. My short leg is 3.5 radical 2 times radical 3. So long leg is equal to 3.5 square root of 6. So this over here is 3.5 square root of 6, which means this over here is 3.5 square root of 6. Three and a half plus 3.5 is 7 square root of 6. So my side length on this problem is 7 square root of 6. My apothem is 3.5 square root of 2. And my number of sides is 3. So area equals 1/2 apothem times side length times number of sides. So area equals 1/2 3.5 square root of 2 times my side length, which is 7 square root of 6, times my number of sides, which is 3. So 0.5 times 3.5 times 7 times 6, or not 6, 3, is 36.75. So I have 36.75 square root of 2 times the square root of 6 is the square root of 12. 12 is 4 and 3, 4 is 2 and 2. So I can take out that 2, and I'm going to double what I just had. So 73.5 square root of 3 units squared. Now the ones on the test won't be that crazy, but that would be how you would take care of that problem. Last question here. I do need to figure out what my height is. I also need to figure out what my base is, but I can do all of that by using some special right triangle stuff. Basically, the angle they gave me in the corner is 60, which means this is short leg. To get from my hypotenuse to short leg, all you do is cut in half. So 12 divided by 2 is 6. And to get from short leg to long leg, we multiply by radical 3. If the entire base is 16 and this piece of it is 6, so 16 minus 6, which means the second base is 10. So I'm going to take 1/2 base 1, which is 10, plus base 2, which is 16, times 6 square root of 3, which is the height. So 1/2, 10 plus 16 is 26, times 6 square root of 13, or excuse me, square root of 3. Half of 26 is 13, times 6 square root of 3. And then 6 square root of 3, 6 times 13 is 78 square root of 3 units squared.